Hey, and welcome back to Gaming for Tokens. I'm Marshall, and in this episode, we're going to be talking about particle effects and how to get what you want out of them, kind of what they are, and some different ways to apply them, and some of their limitations. So, you'll see that I think I mentioned this in the last video. It's been a while since my last video, and I apologize for that. But I think I mentioned in my last video that I was using Unity 5 now, and that is indeed still the case, which is important because the particle engine from Unity 4 to 5, I believe, has some differences depending on the version of 4 that you have. So Unity 5 is out there. It is free. If you want to follow along with this, I would suggest picking up the new version. If you don't want to, I think some of this will carry over. I think a lot of this will carry over. It might just be in different places. But yeah, so I want to give a shout outs to Hallie Orion. I believe that is her name. She's the one that asked for this topic. And as a reminder to everyone else, if you want to request a topic, it kind of forces me to make a video about that thing. So I'm all about people asking for specific things to be made on this channel. Anyway, diving right in, on a particle effect. What is a particle effect? A particle effect is kind of like, so we have a plane, right? We can create a plane pretty easily. And this plane is effectively just a flat card, and we can apply a texture to that. So if we wanted to apply this texture to it, which looks really awful, which by the way, we'll be using this texture quite a bit in this series, this short series. Anyway, if we apply this to a plane, then we get effectively what a particle effect is in its simplest form. This is essentially what a particle will look like. It's a plane with a texture on it, and that texture is applied to the rendering engine in a certain way. So if we want to create a particle effect, it's really, really easy. Over here in your hierarchy, the easiest way that I found to do it is to right-click, hit Particle System here, and that'll create you a particle system. Other ways to go about it, just like everything else, you can go up here to Game Object, and then Particle System, it's also there. But for my purposes, I'm usually going to be right-clicking and hitting things down here in this menu, because it's quicker for me. We're going to zero out the position of it, as usual. And actually, I'm going to put a -2 on that guy, so it's more centered in the camera here. So this is a particle system. And like I said before, it's just a series of little planes, and I'm going to pause the playback on that, and I'll explain this little window here in a second. I'm going to pause the playback on that, and I'm going to change from shaded to shaded wireframe up here in the top left. What that's going to do is it's going to let us see the actual vertices and planes of the particle effect while we have it, well, I guess all the time, which is fine. So yeah, like I said, these are just little planes that are handled strangely in the rendering engine. You'll see that as I zoom in on one of them, it shrinks away and goes off to the side. That's so that you never actually clip through them with the camera. So in theory, you could do a shot like this with your camera that goes through a series of particle effects, and you'll never actually go through them. You'll always go like alongside of one of them. You kind of brush them out of the way. What's really happening is they're scaling down and they're moving. They're scaling down and moving to the right slightly. It's kind of like a screen space scale to the right side. Anyway, that's it. The gist of what a particle system is it's a point in space that generates these little alpha cards that will move in a certain way and have a certain color, and eventually they will die out. So this little guy right here will come up here and then pop out of existence. And all of these are doing that, and all of them are doing it based on a series of variables, which over here on the right, you'll see that there are a lot of little windows. This is the basis of what a particle system looks like technically. So you have your overall kind of umbrella variables here that control how everything starts, like kind of the default values of things, and then you have all of these down here which open up into larger sections of variables that modify these initial values over time usually. Hope that makes some kind of sense. Before I jump into how all this stuff works though, I want to talk about this little window down here, like I said I would. This is the particle effect window. Similar to when we handled navigation, there was a little navigation display. The particle effect window controls the playback of the particle effect. So you'll notice that when I select it, it animates, and when I don't, it doesn't. When I don't have it selected, it doesn't animate. This is also true if I have multiple things selected. So in theory, if you have more than one particle system selected, it will play all of them. It's kind of hard to tell that there are multiples being played there, but there are, I promise. This little guy will control the playback time and speed and things. So if I hit pause, it'll pause it. If I hit simulate, it'll simulate it. If I hit stop, it'll restart it from 0. So the playback time is zeroed out, you can see there. If I set the playback time to 1, I'll see what the particle effect looks like 1 second into its playtime. Same thing if I hit 5. This is what it looks like 5 seconds into its playtime. And then I can go back to 4 and 3. Or I can hover over this playback time and drag from right to left and see it play in reverse order or forward order. So this is kind of a way for me to slow down and see how it looks in, I don't know, in slow motion, I guess, in variable speeds. Likewise, I can put this at half time and then hit simulate and it'll be going in slow motion. Or I can speed it up or slow it down. I can do whatever I need to do to make this look good, because it's being an effects artist is absolutely being an artist, and this little window here will let you see frame by frame exactly what the effect looks like so that you can make it look as good as possible. Same thing with a lot of these variables over here. So I'm going to start this thing over and show you what some of these things do. The duration is how long the effect lasts. So yeah, and all these have little tooltips, by the way, as you see as I'm hovering over this. So this is the if we don't have this looping and we hit stop and simulate, it'll run for 5 seconds and then stop. So there's our 5 second mark. We saw that pass by, and no more particles because the duration is set to 5. If we set the duration to 1, it'll only play for 1 second and then stop. Boop, 1 second, and then it stops. So think of this like how long the overall particle effect lasts. Looping, you kind of saw what that did. In this current setup, if I hit simulate right now, it won't ever. It'll look just like it used to before, except it'll play forever. So the duration isn't really relevant in this current setup of variables. But you'll see how we can kind of mess with these two things, the looping and the duration, to make it look unique. The start delay is how many seconds you want before the thing plays, and I might be able to talk about this, the functional usage of this, in an effect probably in the next video. Maybe in this video, I don't know, we'll see how long it takes me to get there. But if I set this to like 0.25 and then I hit simulate, it'll wait for a quarter of a second and then start up. Make that more obvious, I'll set it to like 1. So now what this means is that at 2 seconds the particle effect will stop, or yeah, because it's going to delay for 1, play for 1, and then stop. So you'll see delay for 1, play for 1, stop. Oh, it's looping. Oh crap. Loop. There we go. Delay for 1, play for 1, stop. So the thing you may have noticed when I had it set to looping is that it only delays initially and then it will play forever. So this is like a buffer time before the particle effect starts playing, and then once it has started playing, it doesn't use this delay again. So the next thing on the list here is start lifetime. So that's how long each individual particle will last. So here, if I hit simulate and you follow one of the initial particle effects that spawns here, throughout the duration of its lifetime, you will see that it will last for 5 seconds, so it'll end at the 6 second mark. Bink, and that was the 6 second mark. The reason why that was the 6 second mark is because of our 1 second start delay, which I'm going to get rid of because it's making math confusing. And the particle effect lived for 5 seconds because that's what this is set to. So wait for 1 second, live for 5 seconds, then die on the end of the 5th second. That's kind of what happened there. Yeah, so this is a good time to kind of segue before I jump into any of these other things. This little arrow here to the right is an option on how we want this variable to be handled. Do we want it to be a flat value of a number of seconds every time? Because that means all of our particle effects will have this exact same lifetime piece, and that's kind of restrictive. So you hit this little arrow here and you can get multiple things. You can get a curve. So this curve will it'll feed the lifetime of the particles a number based on whatever we set down here. So whatever we set the high value is, and I don't know if we can set the low value. I think the low value is always going to be 0. So over the lifetime of the entire duration. So if I set this to 2, for example, you'll see that the numbers along the bottom change. So now over the duration of the particle effect, the lifetime is going to go down. And you'll see this here if I hit simulate. So you'll see that particle effects will start dying out earlier and earlier as the effect goes on. We're looping, so you can't really tell. Here, I'll set this to like 4 seconds and uncheck looping, stop and simulate. And you'll see that as the effect goes on, you'll see it like die off like this. Or, oh, I guess the other way around, whatever. But yeah, so that means it's because the particle effects that are being birthed later in life have a shorter life expected, or shorter lifetime. So they die here and then they die out. So that's kind of how that works. You can do random between 2 constants, which is like the first value, except now there are 2. So now we can say, I want them to live for at least 0.5 seconds and at most 2 seconds. So what this is going to do is it's going to be spewing these out, and they're going to kind of, in a more natural way, die out in kind of like well, it's a more random way, so it looks kind of sort of more natural. Yeah, this is used a lot, I find. Personally, I use the lifetime random between 2 constants a lot. And it's because it tends to just look better if there's a little bit of variance in the lifetime of the particles, but I don't want to have to do the next one, which is random between 2 curves. I don't like the lifetime of my particles being dependent on time personally, but I can see why you would want that, I guess. So if we set something like this to be the case, then we will end up with less variance in the beginning and more variance towards the end. So here. So you'll see that they'll live initially the same, and then they'll be widely varied towards the end here. And if we make this 6 seconds, and we make the max here like 5 seconds, you'll kind of see what I mean. What? 5. Come on. There we go. Okay. So now when I simulate this, you'll see that in the beginning they all kind of live about the same amount of time, but then they start dying off more and more sporadically and randomly as the lifetime goes on. Yeah. So that's random between 2 curves. Now you'll notice that a lot of these have this option, so you can do this with almost anything. For now, I'm going to keep this random between 2 constants, and I'm going to say that it's going to be like between 1 and 3. So what this is going to look like is this. Particles are going to come out, and they're going to kind of die in a random way. All right. The next thing is speed. Start speed. This is the amount of speed, and for now I'm going to set this to looping so we can see how this affects it. The start speed, if we increase it, makes the particles go up faster. It's pretty self-explanatory. If we set this to random between 2 constants, which is also something I usually do, and we set this to something like 3 and 5, maybe 3 and 7 looks good. So we'll see that some of the particles go farther and some of them don't. Some of them don't get that far before they die. So we have kind of two ways to control the distance the particles will travel, which is really what we're doing here. The amount of time the particles take to get to their death and the amount of distance they cover therein. The next thing we have here is the start size, and it's a pretty self-explanatory, smaller, larger, whatever. And again, usually I use 2 constants. So we'll do something like 0.5 and 2. So then we get kind of this effect. And you'll see down here in the bottom that it looks like there's a little bit more depth to it, but it also looks like there's some play in the size of the particles. And you can even go like 3 and 5. And then you get kind of this weird cloudy look where they kind of like meld together a little bit because they're overlapping and because of the shader that it uses, which we'll talk about shaders eventually too. they kind of glom together, and it kind of ends up looking like, in this particular instance, kind of like crappy smoke or crappy steam. And we can make this look like a lot better smoke if we put a little bit more time into it. But yeah, so there's that. Start rotation isn't going to make a whole lot of sense right now because all of these are circles. So you'll see that they're... I'm going to try to... Yeah, so you see that this is just a circle, right? So rotating the circle, you're not going to see any difference. But if I increase this, you'll see that the planes start to rotate, right? But they all rotate by the same amount, which looks kind of weird. So what I usually do, again, is random between two constants. And if you want a true random rotation, just do 0 and 360. And then you'll end up with this. And you might be saying, but wait, why does this matter if they're all circles? Well, see, we'll eventually get to the point where we can plug in a texture to these particles, and then we'll be able to it'll matter a lot that they're rotated or not, because it'll look really weird if they're all uniformly positioned, like if they're all uniformly rotated, because then it'll uniformly oriented is the one that's the word I wanted, because then it'll feel really unnatural and strange. It's kind of like if you've ever seen snowflakes falling, right? They're never falling straight down, and they're never falling not rotating, and they're never falling oriented in the exact same way, right? They're always they're unique because they're snowflakes, so they're always rotating a little bit in a different way, and they're always rotated a different way. And yeah, so this is kind of the starting of that. For now, I will say 0 and 45, and this will give us kind of a similar look, but it'll give us less rotation. Start color. It's pretty self-explanatory. You can make things colors. It's yep. And you can do a gradient. So what this means is if you select that, it'll come up with this. This is another thing we're going to be using quite a lot, is gradients. This is, I believe, going to pick a random spot on the gradient. Yeah, that's what it does. So if we go from white to, say, cyan, then it will choose a random spot somewhere on this. Oh, no, it's over time, isn't it? It is. Okay, so it's over time. I didn't realize that. I learned something new. I don't really ever use the start color for much, but so over the course of the 6 seconds that this particle effect will last, it'll go from this color to this color. You'll notice that up here is alpha, so I can make it 100% opaque, or I can make it 100% transparent if I want to. And this is over the duration of the particle effect. Typically speaking, this isn't how I would do this, but you'll see how I will do things in a little bit here. You also have random between two colors. So I have used this one before, where you say white and you say like red, and it'll choose a color between white and red randomly for each particle, which is kind of handy in certain cases. And you can do random between two gradients. And again, the gradient it's over the lifetime of the object. So if we wanted to, we could do the exact same thing, except for instead of blue, we'll make this orange, like that. So now it'll choose one of these two gradients for each particle, and it'll make that gradient follow that life color or duration color, I guess. So like, for example, at say this point in time, all of these every particle that was born on the same frame is at the same point in whichever gradient it's in. Well, no, sorry, okay. Every single one of these particles is at the same point in this gradient. If this is time, then all of these are at, 2.5 is almost 3, so just under half. So all of these particles that are on screen right now are about here in this gradient color scheme. But which one they're on is random between each particle. That's kind of how this works. If that makes sense at all, I hope that makes sense, because I think that's the best I can do. That's really confusing, sorry. For now, I'm just going to choose an individual color, white. We'll stick with that. It's easy to see, and it's easy to show you what's going on. All right. Next thing is gravity modifier. Gravity modifier is interesting, and it's basically what you'd expect. If something has a gravity to it, it will use gravity. So things start spawning up, and then they fall down with gravity. And the reason why this is an individual scale is because sometimes you want things to have kind of an implied buoyancy. Like, steam has an implied buoyancy, right? If you fire steam out straight, it will go out and then fall because water is heavier than air. Depending on the heat of the steam. The heat of the steam might go up, right? Because if it's hot, then it'll dissipate into the air and become lighter, and it'll go up. Yeah. So gravity is a way to fake that. If we decrease our size here to like 0.25 and 0.5, you'll kind of see what's going on. So things are going up, and then they're going down a little bit. And if we increase this to 0.4, you'll see more of what I mean. They're going up and they're going down. They're going up and they're going down. It's kind of like a fountain, right? So that's the gravity modifier. The inherent velocity is going to be... It's kind of hard to explain. If I type 4 in this, you'll see that... Well, erg. I'll crank it way up. It's kind of hard to notice, but basically what you're going to see is that things are going faster to start and then they slow down. Going faster to start and then they slow down. So that's the best I can do. I don't really use inherent velocity very much. It's not extremely useful, I find. But yeah, feel free to tinker with it. Yeah, it applies the current directional velocity of the transform to newly emitted particles. I'm not entirely sure what this does. Yeah. So the next thing you'll see is world space, or simulation space. You have local or world space, and local space means that if I move this thing around, the particles follow it. So it's local according to this object. So even if I rotate it around, it is a single chunked object. World space is the opposite, where if I move this thing around, it will leave the particles behind. And if I rotate this thing around, it still does that. Oh, that's weird. I didn't realize that. That's dumb. Well, there you go. It'll rotate it around like that. Typically speaking, this is going to be useful for things like if you have a trail of smoke. Usually you want that in world space. Otherwise, all the particles will, when they're spewing out, they'll look like this behind the thing, and it looks like crap. So usually you want it to look more like this if it's trailing behind it, because that makes sense. The only time that you would want to use local space is for really, really large things or things that won't be moving. It doesn't really matter which one you use, but sometimes local space is more useful for getting a bird's eye view of how it's going to look. If you're moving stuff around a lot and you want to see how it looks, local means that you just have to wait less time for the simulations to resimulate, and you can just kind of move the particle effect to where you need it to go, and then it looks good, instead of having to move it and then wait for a second, resimulate, and then let it catch up. It's kind of a preference thing. Typically speaking, you usually don't want to use world space for everything, just because you don't have to, and sometimes it does weird things with some of these other variables. So use world space where you need it, and then use local space where you need it, where you don't need world space, basically. It doesn't really matter, though. This play on awake means that it will either play or not play at the beginning of the scene. So right now, because I unchecked that, it's not playing. But if I unplay, check this, and replay, it will. So now it is playing. So again, if you remember back to the scripting videos, awake is the function that runs before start, and that is exactly what that references. So play on awake means that it will run the particles before start happens. Now remember this, because this is going to come up in scripting later on when we need to script stuff to manage this. Particle effects run before scripts do. That's something I found out in the process of making this video, and that's the reason why the videos are coming out late, because I had to figure out how to script for particles. I thought it was going to be a lot easier than it was. Anyway, yeah, so that's what play on awake does. Max particles is how many particles total we can have on screen. So if I change this to 3, we can only ever have 3 particles at a time, And then when one of the particles dies, it spawns up another one. So there's a reason why that's set absurdly high, and that is that you usually want a lot of particles whenever you're doing something like this. But keep in mind, you can use this as a... it's meant to be a performance limiter. It's meant so that you don't have 20 million particles on screen and your game runs at 5 frames a second. But you can use this as an artistic thing. Say that you have like a grove of fireflies and you want there to always be a certain amount of fireflies in that grove. You can set this to how many you want. Say you always want 6. Now you always have 6 particles. You always know that there are going to be 6 particles. So you can use it as an artistic tool, but you don't have to. The next thing is emission. So now we're getting into we're out of the default values. So these are the umbrella things. These are the initial values that will define the overall particle effect. Now we're getting into kind of the modifier things, the things that will be affecting this particle effect over time. So the first thing we have is emission, which is really important. This is going to be how many particle effects are we spawning. And right now it's spawning 10 particle effects every second because it's time based, right? So if we increase this, we'll increase the rate of particles. It's pretty straightforward. If we set this back to 10 and we set this to distance, it will spawn particle effects when we move, which is kind of interesting, right? You can already kind of start to see some interesting things with this. Like maybe we only want to spawn particle effects on a car while it's moving. That seems to make sense. And then the less particles, the less numbers that we put in there, the less it will spawn. And I believe this is actually like a measure of distance. So for every 0.5 it'll spawn one. No, that doesn't make any sense. I think it'll spawn 0.5 of a particle for every 1 unit that it moves. So in other words, if we set this to 1, for every 1 unit we're moving, it's spawning a particle. But if we set this to 0.1, then it would be for every 10 units we move, it spawns a particle. I believe that is the case. So yeah, that's kind of how that works. For the purposes of this, we're going to set it to time, and we're going to set this to 0. So this will spawn no particles, but you'll notice down here, there's a little bursts area. With this little plus, it'll give us a new burst. What this means is that at time 0 of the 6 seconds, it'll spawn a burst of 30 particles that go up. So we can set this to whatever we want. We can set this to 2 seconds in, and this means that after we've been simulating for 2 seconds, it will do the burst. And this is independent of the start delay, because remember the start delay runs before the duration starts. So this is 2 seconds into the duration. So whatever start delay we have, say that we do 3, now at the 5th second, it will spawn things. So 2, 3, 4, 5. And yeah, hopefully my timing on the video is not off there, because I just realized that would suck. Anyway, so yeah, that's what this does. That's what the burst does. You can have multiple bursts, so you can say this one's going to go off at 0, this one's going to go off at 2. That's 0. That's 2. And these are bursts of whatever particle are in here. If you want multiple bursts of different particles, we have to have multiple particle effects, and that gets into a whole sequence of like timing them together and like lining them up right. And that's all artistic vision and however you want to do it. And that can get kind of messy, but it doesn't have to be messy. We'll talk about how to make it not messy. So yeah, this is our emission. We're going to bring it back to 10 and start sampling it again. It's looping at 6 seconds. We're going to go with shape, and we're going to go over the different effects shapes that there are. I just realized this got all messed up. I don't know how it did. So anyway, your particle effect should start off like this, and it is a cone by default. It is emitting from a cone, as you can see here. So when we open up the shape tab, you'll be able to see the shape. Tab rollout? I don't really know what these things are. I guess they're rollouts? When you have this open, you can actually edit the shape in the viewport here, and you'll see that as you change things, like as I change this here by grabbing this handle and moving it, the angle is increasing and decreasing. just like if I grab the handle in the middle here and pull out, the speed in the base area here is changing, which is kind of weird. So this kind of shows you what the handles are indicative of. Just like the guy down here is the radius. So we have our angle and our radius. The angle is this, and then the radius is this. And the emit from is a drop down for where do we want the particles to come from. Right now it's coming from the base, so they're coming from this little disc basically down here, formed by the base of the cone. And if we want them to come from, say, the base shell, that means they're going to come from the ring instead of the circle. So right before they were coming from everywhere inside of this circle, this disc, now they're just coming from the ring on the edge of the circle. If we want, say, them to come from the volume of this, that means they're coming from everywhere within this cone. Anywhere within this cone is a random spot for them to spawn. The next one is volume shell. So they're now coming from everywhere along the outsides of this cone, not the inside of the cone. So it's pretty self-explanatory there. What do we... Oh yeah, the length now becomes available to us, because now the length isn't determining the speed anymore, because we've changed the emission from. So that's something to note. If you choose random direction, it will kick them in a random direction when they spawn. Normally with the cone, they're always going to be going up in the angle of the cone, right? But if we choose random direction, they're going to spawn in the cone and then go out, like maybe this way, maybe that way, maybe this way. It's random, right? So typically I won't use this with a cone, but we have more options here. We have a lot of options. We have a sphere. It's pretty self-explanatory. We don't have to emit from the shell. We can emit from the inside of it. If we emit from the inside of it, then I believe it assumes that this is a volume and it's spawning from inside of that volume. If we emit from the shell, then it is emitting from the outside of that sphere, from like the surface of the sphere, kind of. And then random direction does the same thing as before. It just kicks it in a random direction, which is kind of what it's already doing to begin with. But if we emit from shell, then we're technically emitting on the outside of the circle, and we always go the opposite direction of the center. So like if you draw a line from the center of the sphere to where the particle spawned, it goes in that direction. That's if you don't have random direction checked. If you do have random direction checked, then it just goes wherever. Hemisphere is kind of like sphere, except it's half of one. I mean, that makes sense, right? So again, it's the same deal. It's just a sphere. You can change the size of it, and it emits from either it or the volume of it. We've gone over cone. We have a box. Box behaves just like you'd expect it to, except you can make it a rectangle, which is kind of handy, especially for certain effects where you want it to, like, say you have a crack in the floor that emits fire out of it. Boom! You have a crack in the floor that emits fire out of it. It's pretty useful. Or like a steam vent, going back to steam. Yeah, that's how we do that. So full circle, did it. So yeah, next thing we have is a mesh. We can define, right now it's only a vertex, but if we actually make it like so this is kind of confusing. If I had a mesh, do I have a mesh? Oh, I have the cleaver mesh. Oh, sweet. All right. So if I put the blade in here, yeah, there we go. My old cleaver mesh from like a super old video. All right. So for those of you who don't know, I did a video a while ago on materials and stuff, and I have this like old model laying around of this like cleaver that I made. Oh, I wish it would show it. Well, maybe I can drop it in here. Yeah, this is the guy. So, yeah, I have this old cleaver that I modeled that I used for demo. Anyway, you can drag a mesh into this mesh area here, and it will use that mesh to emit particles from. So it'll pull the mesh for vertex locations, and it'll emit from the vertexes of that mesh. So you'll see the places that are more dense vertex-wise, like down here and down here, it's emitting more particles from there than it is anywhere else, because there's more vertexes there. So the chances of it spawning a vertex are higher. If you choose... not there. If we choose edge, it'll emit from all of the edges of the mesh. So you could use a lower poly mesh for this, and it would increase the chances of it spawning more uniformly over it. If that makes sense. So if you have like a cube with just the 6 verts, then it will wait, cubes have 8 verts, 6 sides, 8 verts. I'm crazy. Anyway, so if you drop a cube into here, then it'll only spawn in 8 different locations if you have it selected to edge. But if you have it selected to vertex, but if you have it selected to edge, then it'll spawn along all of the like edge corners of the cube, which is much better looking. So right now we're getting particles spawning out of the sides of the blade where we normally wouldn't get them if it was just vertexes. Triangles, it'll emit from the center of the triangle faces, which is weird. And you'll see that this again is reflected on the percentage of where the particles will spawn is affected by the density of the geometry. So where there's more faces, there's going to be more chances to spawn there. You get the same thing with edges, but it's a little less apparent. But yeah. So that's how that works. And then you have the random direction checkbox as well. Now, without the random direction checkbox, the particles will spawn in the normals of whatever you're spawning it off of. So right now we're spawning it off of triangles. So it's going to pick a face like this face right here, and it's going to spawn in the center of it, and then it's going to go in the face direction of that face. So we'll see that like particles that are spawning up here tend to go that way, whereas particles that are spawning down here tend to go this way. So it's perpendicular to that face, if that makes sense. Yeah. So we have circle as well. It's kind of like cone, but just the bottom part of the cone, and it always goes out from it. And we can emit from just the edge if we want, so we can have like a ring. This is more useful and apparent if I do this. 0.2. So yeah, you'll see that it's spawning just along the edge of the thing, but if we do this, then it spawns it on the inside of the thing. And again, random direction just tells it to go in random directions. Then we have edge as well, which is kind of like box in the way that I was using it before, except, oh, I can't do that. Oh, I can do that. Yeah, speed. Yeah, there we go. But it goes in the negative z direction on the z. And we have a radius, which is a weird name for that, I guess. I would go with length, but whatever, more power to them. And again, if you set this to world space, I guess you can also rotate it. But yeah, so you can kind of control the direction of this, and you can emit particles from a straight line, which is useful. You have random direction again. Yeah, if I didn't say that. And that's it. That's all the different shapes. So for now, we're going to go with hemisphere, because I like hemisphere. And we aren't going to emit from shell or anything like that, and we're going to make the radius a 1. We're going to make the radius a 2. I'm a liar. So we have a hemisphere that is emitting particles, and we're going to mess with some of this stuff. So we have a bunch of things over lifetime, you'll notice. So all of these except for size by speed. We have a couple things that are by speed, external forces and stuff down here, but most of the stuff is over lifetime. So what this means is that we will apply a velocity of these things over the lifetime. So if I set this to 2 on the y, maybe I'll have to set it a little higher than that. Aha! See, there we go. All right, so things are going to be moving along the y-axis, which that's a weird axis for the y-axis to affect. Over the lifetime, it's going to apply this velocity to the particles. And you can kind of mess with this to get it to go the directions that you want it to go. But yeah, because it's okay, I understand. So this is kind of confusing because it's looking at the direction that the particles go as positive z. So this this particle right here is this direction is positive z because that's forward for the particle, right? So if I tell it to go faster on this, it's going to go whatever direction it thinks z is. So this is kind of weird. And then y is going to be whatever direction it thinks y is, depending on how it spawned. So yeah, this is kind of strange. And world is going to be, I believe, world space. Like I was describing local space because it's local space per particle, kind of. And then this is going to be, oh no, it's not. It is local space for the thing. I had that in the wrong orientation. My mistake entirely. That's why I was confused. So this is local space, so this is Y, this is going to be Z, and this is going to be X. And if we simulate this and we tell it to go up on the Y, it's going to go local space on the Y here. But if we go world space, then that's just going to make it go up faster, see? And then we can actually make things go down if we want to. And again, this is all over time. And we can have a curve as well that basically this is the what is this? The lifetime of the particle, and this is the amount. So if we set this to 5 and then we say do that, it will, over the lifetime of the particle, it'll tell it to go more down. Yeah, that's the, or more Z, I guess, which is that way, whatever. Yeah, so that's the it's velocity over time. And then, whoa, the next thing is limit velocity over time. Limiting velocity over time is basically how to make it slow down over the lifetime of its lifetime. So if we increase the speed here, why is this? Oh, because it's dampening it. Okay. Oh, it's already doing it. So if we set the speed to something really, really high, like I have it set to, because I couldn't figure out why it wasn't moving, and we hit this limit velocity over time, we'll see that we have a flat speed value over the lifetime of the particle. It will decrease it to 1, I believe, because if I increase this, then things will go faster. So this is the speed that it will decrease things to over the course of its lifetime. If I set this to, say, 3, which is what it is normally set to. Oh, no, it's not. It's set to, something crazy, right? So if we set this to 5 and 3 and 6, we don't dampen it, this is what it looks like. We do dampen it, and we set this to 6, is what it will limit things to over the lifetime of its of the thing. And we set the dampening to higher. Maybe we can. Maybe we just have to, oh, because this is, okay, I get it. This is a percentage. Shows how much the IA. Okay, so this is a percentage of the speed. Yeah, get it. Got it. All right. So now if we say random between two constants, and we say that this is going to be 1 and this is going to be 3, then we get kind of a different way of dampening it. And separate axis is going to let us control specifically what axis we want things dampened on. So if we set this to 0 and we set this to 0, then it's going to dampen the x and the y, or the x and the z, more than it is the y. And if we set this to 1, we set this to world, now you'll see that things are going up still, but they're not going left and right anymore. And that's because we're dampening the left and right, but making the y go, yeah, you guys get it, I think. Force over lifetime will apply a force on the particles over its lifetime. So if we set this to world and we set it to x, you'll see that some of the particles will start to go to the right more, because they're going to go up and then they're going to go right, and they're going to go up and they're going to go right, because we're applying a small force on them, kind of like wind. Think about it like wind. So they kind of go up and then they blow right. Easy way to get like leaves blowing out of a tree or something like that is with this. Sorry if I'm going a little fast. The video is running a little long, and I'm trying to kind of get through all of these, at least some of them, a couple more of them, by the time this video is done. Anyway, color over lifetime is probably the most useful one of these. This is the one that I use all the time. So you have gradient and random between two gradients, just like the start color. And if you open up this gradients tab, you'll see that we can change something, say, to start off black. It'll go from black to white. And then we can also make it, as it goes white, disappear. And this is kind of how you get the soft particle look. The look that particles kind of come up and then they disappear. They kind of fade into the background and they go away. Yeah. Anyway, so this is also important. Color by speed will... It's really, really useful if you have things speeding up. So if you have velocity over lifetime and you set this to be a constant, and we set it to be 222, set it to world, that means that things are going to get faster as they go, and then we set the color by speed to be red to white. Is there a speed by lifetime? It's being silly. Oh, speed range, that's why. 3 and 6, so we make it the same. So now we'll see that the ones that are slower are going to be lighter colored. Why didn't that change to 3? Go to 3 to 6. Yeah, there we go. So the ones that are slower are lighter colored because our speed starting speed is 3 to 6, right? And we'll see that if we check this velocity over lifetime, things are going to be more red than not because they're going to increase over that. So if we say this is going to be 5 to 8, now suddenly we'll see a more wide variety of things, and we'll see things kind of change color as they speed up over the course of their lifetime. So that's color by speed. It's pretty straightforward. We have, again, gradient between two gradients, and the speed range. The speed range is white is now 5 and 8 is now red, and anything below 5 will be 100% white, and anything above 8 will be 100% red. So if we change this to, like, let's see, what is the middle ground here? 6 and 7, we'll see a lot more white. Yeah, because our highest speed is 6 right now. So if we do maybe 4 and 5, we'll see a wider variety, but it'll be more extreme colors and less in-between colors. So we'll see less pink and more whites and reds. Size over lifetime is another really important one, one that I use a lot. I usually end up using some of these. I don't know that I talked about these, but there's these little predefined, I guess, preset curves down here. So you can make your own curve if you want. You can grab this guy on the right and drag him down, but you get kind of this weird, you get an ease in, ease out curve, right? And you'll see that it's changing stuff over here. You'll see that particles are shrinking as they go on in their lifetime. But you can also, say, do this one, which will make them be larger for longer and make them fade out sharply or sharperly. And you can drag this guy over to the right, and it will make that happen at even a shorter period of time. So you'll see that they'll go out and then they'll whoop out of existence, which is kind of nice, depending on how you want to do things. Or you can make them start off infinitesimally small and get to their maximum size. And if you combine this with color over lifetime, you'll see that they'll get large and then they'll fade out. So you get kind of this like weird effect of them appearing out of nowhere and then fading out into nothingness. So I tend to use those two a lot together because they get the majority of your effect, majority of the effect that you're going to want in most cases. And then size over lifetime gives you a curve, 2 constants. So you can say, I want 1 and 2, and then you will have things spawning at 1 or 2. So it's kind of the same as the start size, but it overrides it, I think. Yeah. Size by speed. So again, just like our color by speed, we have a range. So if we do 3 to 6, and then we set this to be, I always say 3, and it always gives me crap for it. 3 to 6. All right. And then we say we want 3 to have tiny little particles, and we want 6 to have really big particles. Then we can do that. Or we can say we can just put it on a curve that's different, and we can do all sorts of more interesting things. We can also say that the faster the particle is, the smaller it is, which, I mean, kind of makes sense depending on what you're talking about. Then the big particles are kind of floaty, and the little ones are kind of not. It's really kind of up to how you want to do things and what look you're going for. Because again, particles can be anything. They can be fire, they can be steam, they can be dust, they can be rocks that fall, they can be anything you want them to be. So it really depends on the look that you're going for. Rotation over lifetime is really great. You can see it happening up here, not down here, because again, rotation, round things don't really go well together. But you'll see that things kind of, as they go through life, rotate. They're all going to rotate the same, though. They're all going to rotate clockwise 45 degrees over the course of their lifetime, because that's what we're asking them to do. But if we say random between 2 constants, and we say go negative 45 to 45, now they're all going to rotate differently from each other. this tends to look a little better, I find, depending on what you're going for, again. Yeah, so there's that. We also have rotation by speed. So the faster something goes, the more it can rotate. So again, we go 3 to 6, and we say random between two constants, and we say negative 45 to 45. What this means is the things in the middle between 3 to 6, so 4 and 5, are going to rotate less than the things on the extremities of our ranges. So this is all determined on the speed, of course. So things that are moving 4 and 5 speed are going to be moving rotating less than the things that are 3 and 6 speed. Yeah. External force. Not entirely sure what this one does, but I think we can have wind zones and things like that. There are where are they? I forget where they are, but we have all sorts of weird effects stuff that we can apply, like wind zones and stuff here. I've never really used these, but they were under miscellaneous, weren't they? So if we apply a wind zone to this, we get this weird little effect that affects all of the particles in a given system. So you'll see that now my particles are going to the left because I have a multiplier on here, but if I change this to 0, then I don't get anything. If I change this to 1 or 3 even, that means that this guy right here is going to blow my particle effects around. So if I hit play, you'll see that it's blowing my particle effects that way. But if I move it, well, I guess it's like a directional light. If I rotate it around so that it's pointing the other direction, it'll blow my particle effects the other direction. So you can actually have things interact with your particle effects in an environment, kind of. So if you have like a hover bike or something, and then you want to drive that through fog, you could do that, and you can blow the fog out of the way. It'll be really, really ridiculous and cinematic, but you could do it. Yeah, so that's external forces and a multiplier on those external forces that are per particle effect, which is kind of nice. So you can have your different particle effects behave differently depending on what it is. Collision gets it's kind of what you'd expect. If you check collision and then you create a 3D object like a sphere and you move it to a place where it intersects with the thing, and you scale the sphere up, and I'm gonna do a little bit of stuff here. I'm gonna make this a cone. I'm gonna make no spoilers. We can't have collision going on before you guys know what's gonna happen. So then we're gonna increase the speed here. We're gonna make it go up. We're gonna narrow this guy down so we have kind of a funnel of particles. Whoop. So now we have kind of a cone of particles going on here. And I want more particles. Alright. So now when I hit play and I move this guy in here, it's not going to intersect with anything because our particle system is set to only interact with planes, but if I set it to the world, it's going to use the world collision system. Right now it's only planes, and the reason why it's only planes is because most of the time you're going to have invisible planes with collision on them that are just set for particles, and then you can have nothing else in the system interact with it. It's kind of how you would do that. So you'd have the ground intersect with particles, but not anything else. We can get a better way of doing this if we just go to world and we set the so you'll see that things are bouncing off of things already, but don't pay attention to that yet. Look over here. We have a layer mask as well, and we can make a new layer for particles, and we can make things only affect the particles collision system that affects it. And the reason why we want to do that is for performance reasons. We don't want every single collider in the game to affect every single particle system in the game. That's insane. So typically we'll like I said, we'll make a new effects layer, and we will assign certain colliders to that layer. That way we can have our collision and our effects be kind of separate systems so that we can control the amount of performance that it takes to run that. But for now, we're just going to set it to collide with everything, and we're going to play with it because why not? It's fun. So, yeah, if I... Well, you get the gist. Whoa. So, yeah. There's a couple different ways that the particle system will handle the collision. There is a dampen effect, which is the amount the particle will be dampened percentage-wise by the collision. So, for example, if we set this to 1, you'll see that the particles will like stick to the thing. They'll stop. But if we set this to 0.5, then they'll move, but then they'll like move slower afterwards. It kind of like slows them down, but doesn't really. And if we set this to bounce, that's the amount that they will bounce off of it. So if they hit it and the bounce is set to 1, they will go perpendicular, or they'll go at a 90-degree angle from their bounce. Here, set it back to 1. So you see the particles are going up, and then they're coming off of it as if something struck it and then came off at an angle, right? But if we set this to 0.25, for example, they'll kind of hit it and then they'll go up and around it, which is kind of more how like a gas would behave, right? So we'll do something like this. And this looks kind of more like a gas. It kind of hits it and disperses, but not a whole lot. And we can even increase this to like 50. Have a lot of particles hit this thing and kind of come off of it. Or if you look at it upside down, it almost looks like water in kind of a weird, kind of crappy way. Maybe? I don't know. Yeah, so that's bounces. Lifetime loss, if you set this to 0.25, 0.25 of the particles will die on impact on it. Or, well, no, sorry. That's not correct. 0.25 of the particle's lifetime is lost when it hits it. So if we set this to 1, all the particles will immediately die when they hit because this is the percentage that their life is lost on it. If we set this to 0.5, half of the lifetime of the particle is lost when it hits this thing. Because again, our lifetime is 6 seconds, or our lifetime is 1 to 3. So if a particle of lifetime 3 hits this sphere, it loses 1.5 of its lifetime, on top of whatever it has already used to get there. So yeah. The minimum kill speed, not entirely sure what this is. Let's increase it. I'm not sure what this does. It looks like it just kind of kills them off. Oh, wait. Oh, so if it's going a certain speed. Ah, interesting. So right now our speed is set to 14 to 22. And if something is going... so actually here, we're going to set this to 0. We're going to set... So yeah, okay. So if we set this to 15, anything that is going 15 or lower? Yeah, okay. This is better, I think. Anything that is going 13 or lower, speed-wise, I think it's being dampened. So yeah, anything that is going this speed when it hits it, or after it hits it, dies. So because we're dampening things, so we don't dampen anything, and we set this to 15, we won't be killing most of them. Oh, what is going on? Okay, so we're only killing some of them. Our speed is set from basically 15 to 22, right? So anything that is going above 15 won't die, but everything that is going below that will. So we lose some of our particles, but not all of our particles. I believe that's how this works. Again, we have our layer mask. We have our collision quality. If we set this to medium, we won't see much of a difference here, but if we set this to low, I'm pretty sure we will. You'll see some of the particles go through. And it's because the way that it's doing this is by dividing all of the colliders in the scene to voxels. If you don't know what voxels are, if you don't know what voxels are and you really want to know, go look them up. It'll take you a couple hours to read about how voxels work, I'm sure. There's brief synopsises all over online, but the gist is it breaks all the collision in the scene. In this particular case, voxel collision is going to break down all of the collision in the scene into chunks, and then so kind of like a grid, and then it's going to make it so that when something is looking for collision, it just looks for the collision in its grid instead of the entire scene. And And then the quality of that is, I believe, how forgiving it is dependent on frame rate. So if something is set to high, then it's always going to be precise. But if we set something to medium or low, then it's dependent on the voxel size and all that jazz. So if we set the voxel size to much lower and we're on medium, then it's going to be higher quality medium. So this is kind of a percentage on the, not a percentage because it's not a percentage value, but kind of the quality level, the lower being the better quality that the collision quality is. So if we set it to low and then we set it to like 0.25, we get a similar result as medium at 0.5 because we're setting the low quality to be of better quality. That's really confusing. I didn't realize how confusing that would be. Anyway, the send collision message, I believe in previous videos we've done the on collision enter scripts and things like that. This will actually feed it on collision enter for every single particle that hits it. If we check this box, that if you're running scripts for collision, that can probably chug your game quite a bit. I imagine that's a lot of script calls to be sending, but yeah, you get the gist of what that means, I hope. If you don't know what that means, look through my videos for video on collision scripting and stuff like that. You should be able to find what I'm talking about. But yeah, that's basically what this means. So that's collision in a nutshell. If we uncheck that, then it ignores everything in the world and just kind of goes about its business. All right. Sub-emitters. Sub-emitters is a whole thing. It's a whole topic, and we will be talking about sub-emitters in probably a later video because this video is already an hour long. That's crazy talk. Sub-emitters are emitters that are attached to your particles. So the birth particles are when a particle is born, it will emit another particle system onto that particle. The best way to describe it is the collision and death ones. So the death ones, when the particle dies, it can explode, and that explosion is another particle system, right? So we can have a particle that isn't like a rock, and it falls and hits another rock, and then it breaks apart and creates another particle system, and then each one of those breaks apart and then produces like a dust particle effect. That's how you do that, is with these sub-emitters. We have texture sheet animation, which we will be talking about. A texture sheet animation, you will typically have a sheet like this of images of an animation, and it will loop, and then you can, well, not always, but it usually does, and then it will go between them like frames of an animation. So you set how many tiles you are on the X and the Y, how many you have in that texture sheet, and how many you want to do that, how much of that sheet you want to use, rather, and then how many frames you want to cover over the lifetime of the object. So again, this is a 0 to 1 value, so over the lifetime of the thing, over the lifetime of the particle, how fast you want it to flip through the frames. That's what it is. Yeah. So like this right here is a linear progression of frames. So at frame 0, or at second 0, it is at frame 0, and at second, at lifetime 1, rather, it will be at frame end. Yeah. Yep. And this is how many times you want it to go over that effect. Yeah. This should be pretty self-explanatory, but it will be better explained when we actually have a practical example in the next video, I hope. I don't know, we'll see. And then the renderer is how you control how it's rendered. So we have a bunch of different things here. Stretch billboard, which stretches things based on these values here. So we have a length scale, which right now we have it set to 0 or 1, so it's going to be spheres like always. Decrease the spawn stuff here so we can see what I'm talking about. And I'm also going to decrease the speed back down to like 3 and 5. So you see that we have circles again. But if I set this length scale to 3, then we have like these weird elongated circles. It's kind of just scaling it based on the length of the object. That's all it's doing. And then we have a camera scale. So if I set this to 3, you won't see a whole lot change. But if I move, while I'm moving the camera, it will scale the object. That's kind of what that does. That's kind of a bad description of what it does, but that's a description. Speed scale is the amount based on the speed of the particle, how it will elongate. So I've used this one before for certain things because I have them like start fast and slow down, and they'll kind of like scrunch and then pop. So you can do some interesting things with it. But yeah, the normal direction is it's kind of hard to describe, but it's the normal direction of each particle. The normal direction is the direction that the face thinks is forward off of it. Basically, don't mess with it if you don't know what it does. It's the best thing I gotta say. But it can make your particles look funky, and if you need to change the normal direction of your particles, this is where it's done. The material, you can assign new materials to it. So, like I have a new material here that I made for particles. This looks really crappy. It won't look really crappy when I use it in the way that it's meant to be used. But I can just drag and drop materials onto that, and it will change. I can also do this and get the list of materials. Oh, it appeared down here. Get the list of the materials in the scene and choose one for it. So like checker pattern. That's a bad example. Cleaver texture. That looks like crap. But you see kind of what I mean by being able to put on textures and things. We have a sort mode. So sorting is kind of weird. If you have none, then it's just going to sort basically by distance. Sort of. It sorts the particles like it sorts objects. So if you have a sphere, it will sort the sphere behind the particles. And then when you move the sphere forward, it will sort the sphere in front of the particles. Just like if you have, say, another sphere, and you put that in front of this sphere, it will sort this sphere in front of that sphere. That's sorting. It's weird to think about sorting if you don't fundamentally understand how rendering engines work, which is that it's just rendering pixels in space on screen, and you can tell things that are farther away to render on top of things that are closer. You can just do that. It's just a thing you can do. So the sorting mode will tell you how to sort the different particles. Do you want to sort them youngest, always in front? You can. Or oldest, always in front? You can. So yeah, that's kind of how this works. Sorting fudge will move the object in front of or behind other things. So I shouldn't have deleted that sphere. Let's create a cube this time, actually. Let's get crazy with it. And I create a giant wall, and I put it in front of my particles, and I make my particles bright red so we can see them on the white wall. We'll make them purple. Yeah, we'll make them purple. So now we have a bunch of purple particles behind a wall, and we're going to mess with the sorting fudge. I really hope this works. I have actually tested this. Oh, that sucks. Oh, well, point is... Oh, I know how to do this. All right, so we're going to take this guy. We're going to duplicate him. We're going to move him up here. We're going to stop. We're going to simulate. And then we're going to change this guy to white. And we're going to set the sorting fudge on him to be 0. And we're going to move him in front. All right. So you see how... For all reasons, for every, we should be seeing the white particles in front of the purple ones, but we're not, because the purple ones are being sorted in front of. See, so this is how it should look, but because we set the purple ones to render behind or render lower, they get pushed earlier in the queue, and they get rendered in front of the white particles, even though we should be seeing them over top of the purple ones. So that's kind of how sorting works and how weird it can be with things. I hope that makes sense. I really do. But there's your practical example right there, is that the camera is here, white particles, purple particles, yet down here we see the purple particles in front. Yeah. So I can even pull these purple particles like way back and behind. And you'll see that actually as I do that, see, there we go. See, they pop in front, but if I move them back here, they start rendering behind again. Right there. And the reason why that's the case is because I believe this is a distance. So the fudge says that this is rendered 63. Well, here, we'll just make it 60. So it's rendered 60 units in front of where it's actually at. So if I move that within 60 units of the white particles, it'll render in front of the white particles. That's kind of how that works. I believe. I could be wrong on that, but I believe that's how it works. Do we want the particles to cast shadows? Of course we want them to cast shadows. Why wouldn't we want them to cast shadows? Because performance reasons is usually why. You can uncheck that here. You can turn that off if you want. Typically, things that like emit light look fine if they don't cast shadows. It looks really weird if fire casts a shadow. In the real world, fire does cast a shadow. It casts a really weird shadow. But because it's not the right kind of shadow in games, we will typically run into us not wanting to do that. We'll just not render a shadow on our particle effects. The other thing we have here is max particle size. So this is the particle size that things can... the largest that particles can be on screen. So this is when I zoomed in through them, like these. Maybe this is a better example. So as I move in here, things will move out of the way and stuff. That's what that is. That's what that's talking about. That's the max particle size on screen. And then sorting layers for like 2D. The 2D side of things, I believe I covered sorting layers in the intro to 2D Unity stuff. This is how you do that. So you can add sorting layers, and you can assign particle effects to sorting layers so that you can sort things in the 2D engine as you expect them to be, and then the order in the layer that they are assigned to, just like the sprites in the 2D video. And if you don't know what I'm talking about, I have a 2D video. You should go watch that. Yeah, and then probes are... There's a whole thing with lighting probes and reflection probes and stuff like that that I haven't gotten into yet on this channel because it's really complicated. But it has to do with the lighting system and how it handles lighting systems. If you're using light probes and reflection probes, this is where you would hook that up. But if you're not using them yet, don't feel bad about that. They're kind of complicated and kind of weird, and a lot of people don't know how to use them, so not a big deal. But this is where you would use them. Yeah, and if you know how to use them, then you'll know what I mean by that. Yeah. This is if you want to see the wireframe of the particle system. So that's the bounding box, effectively. That's all that is. And then if you want it to resimulate, so if we turn this off and we select this guy and we go to wireframe, you'll see the bounding box in screen space. And if we check that, so I forget what that does. I think it has something to do with every time I grab it, it'll restart the simulation, if that's checked. No. Yeah, I don't know what resimulate does. If resimulate is enabled, the particle system will show changes made to the system immediately, including changes made to the particle. Oh, weird. Okay. So if this is checked, then whenever you make a change over here, it'll update that over here. If that isn't checked, then you'll have to actually stop and hit simulate to do that. That's weird that you have to check resimulate for it to not resimulate. That's strange, but that's fine. So that's what that does. Hopefully this all makes sense. I've gone on for an hour and 15 minutes almost now. So I'm going to cut this video short, and I'm going to be releasing another video where I talk about how to hook up fancier particle effects in a scene that I've created over here. Effects tests? No. So over here we have a few things like my flaming cube that I have here, and I'll show you guys how I hook all this stuff up with doing fire and smoke and lighting effects and things like that. I know this animation doesn't look very good. I made it really quick for this demo. But anyway, so we have fire and we have smoke and we have a light actually on here too. So how to get all that stuff set up so that it looks like things are on fire or whatever. Which, I mean, yeah. So that's what we're going to be talking about in the next episode. And then the episode after that, I'll eventually be going into scripting on how to handle effects, because right now we don't have a way of removing particle effects from a scene when they're finished, right? So if you spawn a particle effect, that's great. If we spawn a particle effect in and it does its thing, it plays its animation, and then we want to remove it from the scene, we can't do that unless we tell it to, unless we explicitly tell it to do those things. So I'm going to I have a script that I wrote that I will be sharing with all of you on how to handle that. I also have a script for doing sequences, which I have an effects sequencer here that I'm going to go into, and that'll let you queue up multiple effects in a row to trigger in sequence or over a time frame. And yeah, so that's kind of what you have to look forward to in the coming videos. Again, sorry in the lull in videos, but I'm going to try to get back on top of this horse and ride it into the sunset, as it were. But yeah, so a lot to look forward to and a lot of recording for me to do. All right, well, I hope you guys enjoyed it. Let me know if you have any questions in the comments below, and if you want me to cover anything other than particle effects, or are confused, or I'm wrong on anything, because, man, if I'm wrong on something, let me know so other people know, and I will upvote your comment, and I'll comment on it and all that stuff so that it gets circulated to the top of the stack, I hope. Yeah, that's it, I think. Thanks for watching, and bye-bye!